Hello everyone. Welcome to the keynote address. I am Rosa Garza, a fourth-year math major with a computer science minor at California State University, Monterey Bay.
Hi everyone, my name is Winifred Ibokwe. I'm also a fourth-year math major with a stats concentration, studying at California State University, Monterey Bay. Within the next few minutes, we'll be hearing from Hilary Parker, who's a data scientist from StitchFix. And please, for those watching, feel free to submit questions throughout the keynote address. Now we will hand it all over to Hilary.
Great. All right. Awesome. This is really fun and an interesting, way of doing a presentation and connecting with people. So yeah, I'm super excited to talk, and I'm super excited to be speaking to undergrads. I was really fortunate to be able to have some statistical training in undergrad. Doesn't seem like too long ago, but it was back before this was as popular as it is now, with Joe Hardin at Pomona College. So I'm excited to just be able to, pass along some of the, things that I felt fortunate to receive in my training. So yeah, want to talk about something that I'm really passionate about, which is thinking about the way that we do work in data science, in statistics, and how we tend to learn like the math and the science, and we think about it as a math field, but really there's a ton of creativity in this job and in this field. And as I'm sure you're already experiencing, there's never one right way to do things. And so I wanted to talk a lot about that and how to approach creativity as you're moving forward in these statistics careers. So a little bit about myself. I wanted to illustrate this, that I tried to show a left turn here. So the idea is that I was totally a math and science person in high school. And then in college, I majored in math and molecular biology and was able to focus on statistics. And then after that, I went immediately to graduate school, where I was able to pursue a PhD in biostatistics. And then I took a left turn, as you can see from the diagram, and I went into data science. I started working at Etsy, which is an online marketplace for handmade items as well as crafts. And I worked there for 3 years. And then after that, I moved over to StitchFix, which is a personal styling company. I'll talk about them in a bit. And so yeah, it's sort of like this interesting turn in my career where I went from kind of biology and a real focus on biomedical applications, and then moved over to the tech world and working at sort of these like playful companies, female centric. And but I also think that in general, the things that I learned from the more traditional training have translated really well into this field. So I don't think they're actually as different as they might seem on the surface. So just want to give you a little background, because I'll be using examples from my company later on. But StitchFix is a personal styling site. And so the way it works is you sign up, you answer some questions about yourself, and then you like create this style profile. You answer a lot of questions like, how do you want clothes to fit? What are your sizes? And then you get 5 handpicked items from a human stylist. And then you're able to kind of keep what you want, send back what you don't want. And so like your experience is like, we have, this inventory, and you get styled, and then you receive it at home, and you have this happy experience. And behind the scenes, what's happening on the teams that at this point we have 120 data scientists, so kind of a huge organization. And what's happening in the background is that we're applying machine learning and statistical models to that data that you're giving us, and sort of your behavior as you're using the service. And we're able to create lists of recommendations of items and other aspects of personalization that then the stylists are using in order to create like a very personalized experience. So this is called the human in the loop problem, where it's a recommender system, but then it's also kind of curated by hand before you see it. That's super exciting. Also a lot of statistical challenges where we don't get we sort of have this like interference layer for evaluating our models. So it's super interesting. And then for me personally, it's been really fun to look at this application and think about something that has been a part of really everyone's life for their entire lives, which is getting dressed, and thinking about it from this sort of statistical standpoint. So this was some work from a colleague of mine, Erin Boyle, where she has been looking. We have a game that's sort of it's a game where we show you a piece of clothing and then you rank if you like it or not. And she's been able to take the set of ratings and do some matrix factorization on it in order for us to understand style space really well. And so what's fun for me is that I can take results from models of my colleague and then create things like creating outfits that are all from one section of that space. And then put those back into the machine where people can rate them and see if their ratings correlate with where they are in that style space. So it's just a really fun application. And there's, I've been thinking a lot about creativity because the fact that we're working in this sort of artistic field, and then also we have to think creatively about the types of data products that we create for the experience. So that's just some background for me. And as I said, some examples will go on that later. But yeah, I wanted to get to kind of this title, like cultivating creativity and what I mean by this. And so like, a main motivation of this is I have a podcast with Roger Pang called Not So Standard Deviations, and we've talked a lot about this topic over time of like how to do data science work or statistical work. Roger's one of the faculty members at Hopkins in the biostatistics department, and he focuses on pollution data. So we get together and talk every couple of weeks about like how we're doing work in these different contexts. And so, like in this podcast, one of the first things that he brought up was this idea of he was teaching a class, and a student came up to him at the end and said, okay, so like you've done a really good job of telling me all of the assumptions of these models and what goes wrong and edge cases for, like what not to do essentially. But how do I know what to do? Like, how do I know what I should do? And Roger describes kind of going back to his office and saying, sitting down and trying to like sit down at his desk and figure this one out. And so he posed this question to me at the beginning of the podcast, and we've been going for 3 years, and we didn't feel like we really had an answer to it for 3 years. But now I think we're finally kind of circling around something, and that's what I want to talk about. So yeah, this idea of like, what do you do? So you get a new data set. Right now you've been in school, and I'm sure you've had a lot of projects, like independent projects. And once you get out into the real world, if you will, there's going to be, all sorts of ill-defined problems that are going to land on your plate. They're not going to be like perfect experiments. They're not going to be perfect situations. And so it's like, okay, so what do you do? And I love this tweet discussion from Hilary Mason, where she, posed exactly this question, like, what's the first thing you do when you get your hands on a new data set? Like, what does this process look like? And so there's a really interesting discussion of that, but for the most part, everything was very ad hoc. It was like, oh, well, I visualize the data, or I do this or that. Like there was a huge number of things. There wasn't like one thing that everyone did. And I think in general, there's not a great answer to this right now. One of my favorite sort of visualizations of this process is from Hadley Wickham, who's one of the he's an R developer who creates a bunch of packages. I highly recommend them. And he has this kind of paradigm where it's like, okay, you're gonna get the data, you'll probably do some cleaning up because of tidying the data, but then you get into this sort of cyclical process of, okay, you're taking the data, you're transforming it, you're visualizing it, you're modeling it. You might start with just some simple stuff like histograms of the data, taking means, maybe log transforming it if it's all, bunched up on one side. But in general, it's not like you just do one, then the next, and it's a linear progression. It's sort of this, dialogue. And then eventually you kind of exit that playful space in there and you get to the communication part where you start to pull together a narrative, pull together a document, an analysis, and say, okay, here's what happened in this data set. But for the most part, when it gets to that kind of cycle part of like visualizing, transforming, you start to hear a lot of people say like, it's an art. And so it's kind of ironic that's like data science is an art. But I think there's in general this sort of hand waving that starts of like, oh, you know, like I don't know how to articulate this, but you just have to be creative. And you see this pop up everywhere. So Roger, my co-host, and Elizabeth Matsui wrote a book about this. And I love this is the very first quote where he's saying, you know, data analysis is hard, and part of the problem is that very few people can explain how to do it. It's not that there aren't any people doing data analysis on a regular basis. It's that the people who are really good at it have yet to enlighten us about the thought process that goes on in their heads. So I love that, where it's like, you know, people obviously do this and do this well, but they can't really tell us what's going on. And I think that tweet discussion from Hilary Mason really emphasized that, where it's like, yeah, people can kind of describe like I make a histogram or I do, you know, a few things, but when you get into that sort of cyclical process, it's people aren't good at telling you what they're doing. There's also, I found dug up a recent presentation, Zen and the Art of Data Science Maintenance, which is a play on this book, Zen and the Art of Motorcycle Maintenance, sort of one of the first books about Zen in the West from the 60s. And so he talks about kind of the, you know, like, what does it look like to have a data science system in an organization? And he talks about, you know, data science as an art. It's a lot of intuition. There's a lot of qualitative insights that go into it. And I love this articulation. You end up exploring the problem that you're presented with through iterating in solutions. Has this great, you know, quote from Pablo Picasso, inspiration exists, but it has to find you working. Another article I came across in doing research for this talk, there's this article about kind of like data science and business and what's it going to look like, especially with more automation. And this guy says, you know, the demand for right brain thinking is increasing, and in an era of increased automation, the need for the arts of data science will be the increasing cry of business. So yeah, this idea of like, you know, kind of like the artistic side of your brain is at work. So I think that, you know, is an interesting articulation of the problem. And it's like, okay, well, if data science is an art, then why don't we teach it like the way we teach arts? We kind of teach it like we teach science, right? And so in order to dive into this question, I, you know, looked at like an N=1 sample of how we teach art at, you know, in art schools. And so this is, I went to Hopkins. Hopkins has a really fantastic school, the Peabody Institute for Music. And so I took a glance at their sort of areas of study and how they approach education. And you know, the first thing that jumps out is that there's a ton of focus on instrument. Totally makes sense. You go to music school, you probably play an instrument that you want to get good at. So you know, you have this like whole list of instruments that you learn. But then there's also this focus on two other areas. One is pedagogy and music theory. So the idea of like there are theoretical frameworks for music, like there's the, you know, length of the sound waves, and there's you know, things that are harmonized, dissonance, the way that like kind of humans want to hear music resolve. So there's a lot of theory involved in music. And then finally, there's the idea of composition. How are you going to take this theory, take this instrument you have, and put it into a piece of music? Like, what does that process look like? And they have, you know, like training in it. You can actually get degrees about it. So the idea here is like, okay, so they teach these three things. They teach music theory, instrument, and composition. And so in our world of statistics, I think there's clear parallels, where for music theory, we have like statistical theory, mathematical theory. For the instrument, like this mode of expression that musicians use, I think that our version of an instrument is the programming language. So the thing that you're using to write in, the language you're using to express this theory into like actual application to data. And then this composition part is, in my mind, the statistical narrative. So what's the narrative of your analysis? What's the story you're trying to tell with the data? How are you making a point with the steps in that sort of cyclical process of visualizing the data and understanding it? How are you pulling that together and communicating out? And so, my experience of the field, again, I came from like pretty traditional training in statistics. And so I want to kind of go through like what it was like for me to touch these three aspects of this art. And I also totally recognize that this has probably changed since I was in school. And I've seen so many teachers, so many professors who are really energized around teaching data science and teaching statistics and, thinking about all this stuff. So this is just my experience. I'm sure it's improved. But so from my experience, like theory, I just want to give that one a big check mark. Like, I think that in general, data science statistics training, there's a huge focus on theory. I think that's good. That's appropriate. It is the fundamental building block of all the work we do. But it's like, okay, we got this one. Like, we got it covered. No need to discuss. In terms of the programming language, I think that that's something that I think I've seen a huge improvement over the last 10, 15 years, where you see, a bunch of development in the R world, in the Python world. I know there was a big analysis of like the contribution of the programming language pandas within the Python, or the programming like domain specific language pandas within the Python world, that really exploded the use of Python for data science. So the point is, there's been a huge development of programming languages, and I've seen the training around that also increase over time. So people seem to understand, like, you have to be competent at programming in order to do this work as well. And what I want to emphasize here is that I think what's making this, data science revolution possible is that there is an emphasis on fluency. So before, we were talking about musical instruments, and you have to learn it well enough. Like true musicians, it is not like you don't have to focus to hit the right notes, or I played piano and I was always like thinking about, ooh, like, did I get that note right? But once you're like trained enough as a musician, it's just like that is like your language that you use, and it's very easy. And so I think with programming languages, they're getting there. Where again, Hadley Wickham, this big R developer, I love this quote from him that was actually from 2013, so a while back now, where he said, when you're doing data analysis, we may find that there are two bottlenecks, and those two bottlenecks are what you want to do and how you tell the computer to do that. A lot of his existing work has been more about how to make it easier to express what you want. And I bolded express because I think that gets exactly at this fluency issue. So, I think there's so much more to say here, but I think the one thing I want to sort of impart on this is like, in terms of being a successful data scientist or statistician, I think it's really important to focus on one, identifying and using tools that focus on that kind of user experience as a programmer of being fluent and allowing for fluency. And I think R and Python are both really focused on that. So I think you're in a good place. But I just encourage you to think about it that way. And as you're making decisions about what languages to learn, I think that it's really, I found it to be very helpful in my career to learn one language well rather than try to like know a little bit about each language. And the reason I think it's good to know a little bit, but I think in terms of doing the work, it's really that fluency part that's most important. So I'm going to give that one a check, even though, like I said, there's a lot more to discuss, and I think that's a more recent check mark. But I also just kind of want to get to the thing that I am talking about for this talk, which is this idea of the narrative. And so my experience in the field, like doing my PhD and the training before, is that in general, the way that I was taught narrative was just to kind of like do it and then get feedback, which is to say there wasn't a lot of guidance. And so I think that's effective. Like, I think, you know, that's one way of teaching it. But in general, I'm going to give this one an X. Like, that's not something that I think we have a lot. I don't think we have our arms around what it means to teach people to do narrative. And so that's sort of what I want to do today, is like try to give you some guidance on how to approach this like softer aspect of data analysis, rather than just say like, oh, it's an art, you know, you'll learn it over time. So in terms of, like I said, I kind of took this left turn into tech. And so I think I've learned a lot from that in terms of this kind of softer aspect of developing analyses. And so I want to talk about that. And so one of the main areas where I've learned a ton is the field of product development. I had no clue what those words meant when I was starting out, so I want to articulate them now, which is that, like, I mean, so for like in the world, let me just check my, yeah. So in the world, like when you're talking about product development, you know, you're literally talking about something like a chair, where it's like, okay, you want to make a chair, someone asked you for a chair, you want to make it. And so what does it look like to actually bring this chair together and, you know, make it a thing? And so you can see here, this is from like someone discussing kind of a course, and this is one of the students in the course going through a bunch of different designs for a chair. And presumably, you know, there's some places where she's like, ooh, what should the legs look like? Should they be round or square? And, you know, what sorts of patterns should we use? So, you know, this is what like designing a product or developing a product would look like in like the real world. And then in the tech world, it's something more like, you know, designing a website. And so that, you know, like for example, this screenshot I have of StitchFix, we consider the homepage a product. And so when we talk about product development, it's like, okay, how do we make all the decisions about what this site looks like? Where do we put the buttons? What sorts of clothes do we show on there? What do we want someone to accomplish when they get to this site? You know, probably we want them to sign up for the service. And so developing this is like more, you know, this is a screenshot from someone else's product development, but it's like you end up kind of mapping out the user journey, we call it, making decisions along the way and just saying, okay, so what do we want the person to do when they come to stitchfix.com and they don't know anything? So that's sort of what I'm talking about with product development. And one of the reasons I learned a lot about product development at Stitch Fix was that one of our main products is this data science system, because it is really fundamental to what we do. We're not just setting stylists loose on like a huge, you know, I think we have something like 30,000 items at least. So that's a pretty tall task to be like, hey, go find this person something in this huge stack of clothes. So instead, we like do some of that heavy lifting for them ahead of time so that they can like more reasonably style a person. And so because of that, because data science is so infused in the product itself, I'm able at Stitch Fix to participate in product development a lot more. And so I, at one point, like now probably almost 2 years ago, I was tapped to participate in designing an internal product, which is, you know, this essentially the UI that stylists use when they're styling someone. And so this is like, I was really excited to participate. I worked on data collection issues that were very closely related. And so I was asked to participate in a design sprint. And so a design sprint is a way of quickly prototyping a product. And it was developed at Google Ventures by a couple people who work there. Google Ventures is a venture capitalist firm. For those of you who don't know, I knew nothing about tech. So for those of you who don't know, venture capital is just, it's like the way that startups are funded in their very early stages. So it's kind of like investment bankers for the tech world, where they're like, oh, we want to, you know, give money to this little teeny tech startup with 3 people, and we think it's going to be a big thing, and we're going to give them money, and we're also going to help them get their vision out the door. And so this venture capital firm would actually go to all their different startups and run this week-long sprint where they're like, okay, we want to leave this meeting this week with a working prototype of the thing you want to make. So like the website or the little robot or, you know, whatever you're making. And so they're able to like really hone this process over time, because they approached it in a very empirical way, and they said, okay, you know, what's working, what's not, and they used the idea of like product development and design, some of the principles that were coming from there. And so, like I said, it's just this full week experience where you have a very mapped out week where they're saying like, okay, on the first day you map out the problem, then you sketch solutions, then you decide what to go with, then you prototype your thing, and finally you test it to see if it's, you know, actually working or not. And it's quite prescribed. I mean, they actually go down to the minute, where they're saying, okay, you know, when you're doing the sketching, you're gonna like sketch alone for a while. We're gonna like warm you up by doing these crazy eights, for example, where you just rapidly sketch one thing a minute, for 8 minutes, and then you'll spend some time just doing your own map of what you think the website should look like or what you think the robot should look like. Um, and then you come together and you make decisions. So, you know, I'm not expecting you to read all this, but the idea is that as you've each come with these designs, you come together and they have a very prescribed way for how to decide, okay, we like this part of that problem and this part of that person's solution, and so we're gonna, you know, pursue these things. And I really like the process. It like you're able to like hear each other. There was a lot of validation of everyone's ideas, and like, you know, no one feels unheard at the end of it. And a group of, you know, 5 to 6 people can come together around one idea without like a lot of hurt feelings, in my experience. And so I thought it was really cool. I was really impressed. And so I was like, I wonder if we can do this for data science. And so I actually decided to try exactly that, where it's like, okay, we do a lot of creating these recommender systems, creating that matrix factorization I was talking about. And so how could we, you know, design that system so that it's maximally useful? We've done a really good analysis. We've thought about, you know, all of the different stakeholders. We've thought about what they want, and we're going to build a solution that works for them. And so like the design sprint, as you can see in this photo, there's always a lot of post-it notes. It's like a very post-it note centric thing. And you sort of group concepts together. So this was like, we were doing a design sprint around a sizing algorithm. You know, we have clients who've told us their size, and then we send them items and they tell us if they fit or not. So we can use those two sources of data to like triangulate around what their like, you know, we call it like latent size or their learned size is. And so there was some like interesting themes that came up when we were doing this design sprint around like, you know, was the item supposed to be like loose and baggy or tight, and like, you know, how much are people loyal to their brands, how much do sizes vary, you know. So like a bunch of these things were coming out, and then we were able to start sketching out solutions of like, hey, what if we have this one model and these are the inputs that came in and this is what came out, and these could serve these different purposes. And so like I'm just trying to illustrate the fact that it is possible to do a design sprint for an algorithm or even for an analysis, right? Like an algorithm in many ways is just a productionized analysis. And so this has been a really fun process, and I thought it was very effective. I feel like it has been very effective. And so like zooming back out, what I'm trying to illustrate with this story is just that I started to be like, hey, there actually is a way to start to be a little more structured around like this softer side, like designing the right thing and taking into account everyone's viewpoint and listening really well to the people that I'm doing the analysis for, designing some sort of product, like data product for. And so I started to think a lot more. I started to look into this design discipline in general. So yeah, again, design is like this idea of, it started with product design around like chairs and stuff, like literal physical design or architects. And so there are academics who study the way that people design objects or design experiences like full time, like it's its own academic field, relatively new. And so Nigel Cross is one of the professors who's been extremely like pivotal in defining this field. So he has some great books, Designerly Ways of Knowing, Design Thinking. So I started to look into these and I found some really interesting themes that were coming up that sounded a little familiar. So one of the themes that came up a lot is like, you know, like, oh, actually, first let me tell this quote that was, I found this quote early on and it just felt like, oh, this is starting to get at this problem we've had of not being able to articulate how to do data science. And he says here, designability is in fact one of the three fundamental dimensions of human intelligence. Design, science, and art form an and relationship, not an or relationship, to create the incredible human cognitive ability. And so what I really like there is that it's like we were talking about data science as an art, but we couldn't really figure out how to put it all together. And so I was like, oh, this is great. There's like another one out there that might have a little bit more articulation around this thing that we kind of don't know how to do well or don't know how to explain well. And so some of the themes that came out that felt pretty relevant were one thing that comes up in this design thinking literature a lot is the idea that designability is often treated as this like mythical, mysterious talent where you don't know how people have it. Like, you know, Steve Jobs is just a genius and comes up with this idea of the iPhone and who knows how. But you know, that's not helpful. And that sounded very familiar with that quote I shared earlier from Roger Peng's book about data analysis being hard and people not being able to articulate how they do it. And so I thought, you know, that sounds about right. Um, there's also a big interesting kind of focus of design thinking, which is that design process is a very solution focused way of thinking and way of operating versus very problem focused. One of my favorite things here was this idea that there was they did a study looking where they gave both architects and scientists a task. The task was like organizing these colorful blocks into appropriate pattern. And there were some rules about how the blocks could be arranged that were stated and some that were not stated. And what they found was that the scientists generally were really trying to figure out those rules that were unstated. So essentially they were trying to understand the problem and define it fully, versus the architects were much more solution focused, where they're like, okay, there's some rule, I don't really care, I'm just going to iterate through solutions quickly until I get to one that's working. So there was less of focus on understanding the problem and more focus on understanding like getting to a solution. And I think this really like hits home that quote from Roger Peng's student a while back about kind of like, okay, you've told me how to diagnose the problem, understand the problems, look out for the problems, you know, diagnose the issues with the data, but like you haven't really focused on this sort of creating a solution for it. And so again, I think, you know, we've nailed the science part, but we've left this design part out. Another thing that comes up in the design thinking literature is that design is this very constructive thinking process. By constructive thinking, and what they mean and what I mean is that you need to start building your solutions in order to understand the problem fully. And this goes back again to that quote from the fellow who was giving this Zen and the Art of Data Science Maintenance talk about like, you know, data science is really an art because you explore problem through the solutions. So you start making the solutions in order to define the problem. Another thing that comes up, they do a lot of studies with people who have their lobes of their brain disconnected. I can't remember the name exactly, but it's like this thing is severed. You're still able to function as a human being, but there's just some processes are impaired by the left brain not talking to the right brain. And they found that that really impacts your ability to do design work. And so the conclusion there is that design process employs both the left brain and the right brain. And so that gets at this quote from earlier about, you know, like we need to use right brain thinking in data science. Like the left brain thinking is a given, but we need to bring in the right brain thinking too. My favorite parallel, though, I mean, you know, at this point I was like, wow, seems like this is on to something that we are circling around ourselves. But my favorite parallel is that Nigel Cross actually spent a lot of time trying to define design thinking itself, and what he came up with was this idea that it's actually a form of non-verbal rhetoric, which is to say that when designers are doing work, the thing that they're usually doing is like sketching something and looking at the sketch and then resketching it and like looking at the sketch, and they kind of are doing this iterative process, but there's no words involved, they're just like drawing. And so there's this really great quote that, you know, just to kind of drive home this idea that sketching is this nonverbal rhetoric, where Nigel Cross is saying, you know, one thing that is clear is that sketches enable designers to handle different levels of abstraction simultaneously. Clearly, this is something important in the design process. We say that designers think about the overall concept and at the same time think about detailed aspects of the implementation of that concept. So you're both thinking about the broad picture and the system you're operating in, but then you're also thinking about, you know, like, oh, is this like little like aspect of my chair going to be structurally sound? And what I love about that is that it gets into this idea of what I was describing initially, of this sort of cyclical process of transforming your data, visualizing it, modeling it, you know, iterating through, where people clearly aren't articulating in words what they're doing. Otherwise, we would know what they were doing. Instead, it's this form of sort of internal rhetoric of like, you know, thinking and like thinking about the details of the data, but also being like, does this tie into my big overarching hypothesis? So I think that when we do data analysis, that process of creating graphs, of looking at model results, that is a form of nonverbal rhetoric that we're engaged in. And so it makes sense that we can't necessarily articulate it. So like after exploring that all, I was just like, okay, this is the answer. We need to start bringing in design thinking and thinking about data science as, you know, a science and design. And that, you know, you're always designing things. You're designing analyses, you're designing recommender systems, you're doing it like designing experiments. And so, you know, I sort of was like, okay, we shouldn't say the art of data science, we should say design for data science. But I think that like leaves the art aspect out. It kind of throws art under the bus. So I wanted to spend the last few minutes of this talk, you know, talking about, well, is there still a role for art? And you can imagine that my answer will be yes. So in order to think about this aspect of data analysis, I wanted to talk about like, okay, so what is a success when you're doing an analysis? And that can be kind of hard to define. It's like, well, is it successful if it's mathematically accurate? Is it successful if, you know, no one says that it's wrong? Like, what does that mean? I discussed this at length on the podcast with Roger, and you know, we kind of came up with this idea that success is when you elicit an aha moment for someone, when it's like they're like, oh, I get it. Like, I see what you're trying to say with this analysis. I see, you know, what you've just built with this algorithm, and I get it. I'm bought in. You know, I believe you that this is the right way to approach this data set. And so, you know, like Roger was able to kind of tear this apart and, or like, I don't know, like, that's not the right way to say it, but like he was able to like really chew on this. And he wrote a very long blog post, which I highly recommend, where he proposes that this definition of success, which is that a data analysis is successful if the audience to which it's presented accepts the results. And so there's some key things there, like, you know, who are you presenting to? What does it mean for them to accept it? Does that mean, you know, like that doesn't say anything about whether it's right or not, right? And so what's interesting about this kind of acceptance moment for someone is that it is, you know, only observable to that person. Like it's a first person experience. You can kind of see when someone has it, but you don't necessarily know like what was going on in their brain when they had that moment. Um, And usually people are very bad at articulating what went on in their brain when something happened. Usually they're just rationalizing, or, you know, it's that can be actually fairly hard to get at. So you can't necessarily rely on someone telling you like, I need to see X, Y, Z, and then I'll be convinced. Like, maybe that's true, but that might also not be true. So yeah, people are unreliable. You can only rely on accounts. And in general, what I've seen in the field is that when you kind of hit this aspect of doing a data analysis or getting the training, people give you sort of like, again, like not super helpful advice where they're like, yes, you should think about your audience, or you should build good partnerships, or, you know, communication is important. Which, you know, I think those things are true, but I just don't think they're very actionable. Like, what do you do in order to think about your audience? Like, how do you get better at that? And I've seen so many people struggle with this aspect of it, where they do really, really top-notch statistical work, but, you know, it just doesn't land with the audience. And then they're like, ah, this was right. I wish that I had, like, you know, like, why couldn't I convince them? And so I think the key thing here is that what we're really talking about is empathy. And so just to make sure we're all on the same page, I pulled this definition from Wikipedia, which is empathy is the capacity to understand or feel what another person is experiencing from within their frame of reference, i.e. the capacity to place oneself in another's position, in another's shoes. And so that's sort of what I'm talking about with this aha moment. Like, you can't necessarily rely on them telling you, you have to like feel it yourself. Um, and so what I think is interesting about like those design sprints I was describing earlier, and sort of other design processes I've come across in the tech world, is that they always have these rules for playing nice, I call it, where, you know, earlier I listed out kind of the way that you make decisions in a design sprint. You like make sure everyone's heard, you validate each other's ideas. So essentially it has like the empathy step like baked into it, where you're listening to stakeholders, you're listening to your coworkers, and you know, you can definitely like follow these rules. The rules are kind of like, generally they're about non-judgmental observation of other people's like things. Your ideas are originating from the people you're like building the thing for, like creating the analysis for, creating the data science product for, and you're listening, validating. So like, you can start doing design processes like design sprints, and you can follow all the rules, and you can grit your teeth through like not judging other people's ideas. But what I want to say in this last part is just that you can actually work on like feeling those things inside too. So if you're someone who like thinks, you know, I'm just not a very empathetic person, and you know, that's frustrating, and I can't get people to accept my analysis, and I just wish they would accept it. Like, you can actually work on the part of you that um, you don't have to feel that frustration. It is possible to start to feel a little bit more like, oh, I'm increasing my capacity to listen to other people and give them what they need. And so when I say like cultivating creativity, what I actually think is important for this talk, and for like, I want you to walk away with, is this idea that you can kind of cultivate empathy instead. And so you know, this is going to be I'm based in San Francisco, so I'm always like, this is a very San Francisco moment of this talk, where I want to talk about my experience with meditation. So I'm giving this talk from the San Francisco Zen Center, with a bunch of monks that I have, you know, here. My partner, Michael, he's the tallest guy in that photo, so he is a Zen priest. And so I met him through exploring meditation further. You know, I moved to San Francisco, and it was basically required by law to like start meditating. And so got really into it. And so like with Zen Buddhism, and you know, this is just one philosophy I want to share because it's close to my experience. It's by no means am I telling you to go and like, you know, practice Zen Buddhism, but like in general, what I found with this specific philosophy, I would call it, is that, you know, there's the central practice of meditation, and the reason you do it is because you're cultivating this ability to observe yourself non-judgmentally, and with a lot of curiosity. So like, if you're like mad at your business partner, you're like, I wish they just understood the central limit theorem. Like, you can, instead of like getting mad, I should say that anger will arise, but you can, instead of like acting on it, you can be like, oh, isn't that interesting that I am getting so upset about the central limit theorem and this business partner, and let me be curious about that. Like, I wonder why that's happening, and I wonder what it feels like in my body when that happens. And so you kind of practice that over and over, and it really increases your ability to kind of accept what's going on around you without reacting to it. And the reason that this is important, like why does acceptance matter, is that as you cultivate your ability to kind of accept the world around you and to accept the feelings that are arising in you, it'll increase your capacity to accept others and be connected to others. And so why does this matter for data science? Like I said earlier, I really want you to walk away with the idea that like you can, these soft skills that I'm talking about with design thinking, of like, you know, being able to empathize, being able to listen, like these are things that you can work on, and you can, you know, develop. And so, like, you know, when I think about the design of data science, this is really about, you know, accepting the audience that you're presenting to, so that instead of like fighting with them and saying like, why don't you understand the central limit theorem, you can just like accept like that's where that person's at, you know, this is the way that they think, this is like what motivates them in their work, and you can craft an analysis around those motivations. So you can, you know, maybe someone who's like a CEO, it's going to be more important to them to hear like, how's this going to help the business, than to hear like, I really understood all of these like, you know, edge cases and statistical issues, and it was so interesting, I had to use this bias correction term. Like, that's not going to be something that interests them, motivates them, and so you really need to tailor your analysis for them. And what I'm saying is that, you know, by building this skill, it doesn't have to be meditation, but just by like by building this skill, you'll be better at understanding the people you're presenting to and building for, and therefore like building things they need. And then when I talk about the art, I think that this acceptance practice of like yourself can be so critical, especially for like a lot of people, you know, kind of coming up in the Western world in science. There's so much self-judgment, so much self-criticism. And so as you build a capacity to sort of accept yourself and accept what's coming up for you, that will actually help you to kind of express yourself artistically. So like to explore like some crazy idea where you're like, what if I made outfits from all of these weird items that are showing up? And, you know, you kind of like allow yourself that space to pursue your ideas without being your own worst enemy and being your own worst critic. And I bring this all up because like it's something I've been doing. I have noticed my capacity for this increasing. And so I want you to walk away knowing that like you don't have to do meditation, but there are ways to build this part of the field in addition to learning the theory and learning everything. So in conclusion, I want to leave time for questions. So, you know, my three main takeaways, data science includes all of these forms of human cognition, science, obviously, art still there, and then design thinking. Design methods, so like all of the, you know, literature, all of the, you know, practices such as design sprints can be leveraged for learning the how of data science. And then finally, you know, this art part, empathy, that can be, that's like a very, you know, that's something that's central to data science, and skilled use of using empathy is key. And you can cultivate that. That's not something that you're born with. That's not something that's set in stone. And cultivating that will be very good for your career as an applied statistician or data scientist. So with that, thanks so much for listening. I wish I could see everyone's faces, but I would love to take some questions now and hear, you know, what your thoughts are.
Okay, thank you, Hilary. Now we'll open it up to questions. If you have a question, please type it in the question box. So for our first one, it's from Nicole Pereira. As a recent graduate, what are the right steps to take to get into careers using data science or statistics with no prior experience in those areas?
Yeah, that's a great question. So I think I mean, obviously it depends, and I certainly don't want to suggest that there's one path, because if there's anything, there's absolutely not one path for, you know, building a career in this field. But I think that some effective strategies, you can always like, you know, do a traditional route, get a master's. But I also think that in general, like there's data science is such a fundamental part of all jobs at this point. Like data is, the data revolution is happening, and so I think it would be really effective to, pursue any sort of job in, tech or in whatever field you're interested in, and just start like bringing in data methods. So allowing the work to present problems to you that you could solve with data. So I think I've seen people do that, and I think it's really effective. And I certainly, even though I took a more traditional route, I have very successful managers, director levels. I mean, even our chief algorithms officer, he has a master's in statistics, but he's not like, I would not call him like a traditional data scientist in terms of his training. So I wouldn't let the training route hold you back, and I would just, bring a lot of passion and enthusiasm to solving real world problems with data.
Okay, thank you for your answer. The next question was from Sarah Bond, and she asks, how do you deal with bias in machine learning and modeling?
Yeah, that's a great question because I guess so. There's sort of two things. Like for example, I talked about bias in our data set because we have like stylists who are choosing clothes for the person, so we don't even get to observe our algorithm's performance firsthand. So I mean, that's an active area of research. I don't want to act like there's any answers there, but in general, thinking systematically about the problem, and then I would say thinking systematically about the problems, and then also thinking of new data sets that you can collect that will help you get around some of these things that might be biasing your data. So like, for example, we started that rating game, and so all of a sudden we're getting direct feedback from clients about whether or not they like clothes rather than having this intermediate layer. So there's, I don't want to act like that's a solved problem, but it's definitely important. And then I also want to take like, the more general idea about that, like bias in terms of like prejudice, like gender bias, racial bias. I think that is like such an important topic that I feel passionately about. Obviously, when you're talking about clothing and talking about like people's identities, that's like a huge issue. And so I think in general, like just educating yourself on how there might be bias in data sets, and I think being present in the room and bringing up those issues as often as possible is really important. I found that in general, like the culture of the company you're at is probably the best deterrent for bias issues, because it's not like the bias isn't like obvious. It pops out at you if you see it. So like, for example, I'm thinking of there was like a predictive policing algorithm where it was like, let's send policemen to where there's been a bunch of arrests, and it's like, are you kidding me? Like, of course there's been arrests in certain neighborhoods, and then you're using this algorithm to be like, let's send more people to that neighborhood. It's just sort of a self-perpetuating machine. And so that's the type of thing that, like, with some training, that really will pop out at you. And so developing trying to be present in the room and having those conversations, I think is really key. I think I don't want to say just like try to work somewhere where that's not an issue, because it's important for people to be working in the places where it is an issue. And so, yeah, I would say, I mean, in those instances, it's almost even more important to kind of develop those soft skills so that you can become a trusted partner, start to bring these things up, start to propose solutions. People really want to hear solutions to problems, not just like, hey, this is a problem in a business setting. So being creative about how, like, I think actually the design thinking ties in terms of like, well, how could we design a system that accounts for this bias or like corrects for this bias, or even like empowers people who might have been disadvantaged earlier. So I would just encourage you to be creative and not be afraid to be the person driving solutions for this. Yeah.
And so our next question is from Cassandra Plataniak. I read an article in the Wall Street Journal about customers who worked in the same office and used StitchFix. They received custom outfits, but at least one piece in their custom product was the same. What is the algorithm in determining the custom outfits?
Yeah, no, that's a good question. I remember that article coming out, of course. I mean, so like the idea here is just like we are not like creating one piece of clothing for every person. I wish we were, but that's not where we're at. So like, you know, like any kind of e-commerce company, we're going to have like lots of items. And in general, we look at like all these kind of like demographic information, and then also your behavior in the past. So like two people working in the same office, they are likely to be similar. Like, and, you know, I certainly dress very similar to my coworkers. And so in some ways that like comes up in the data. We don't have any sort of like control right now for like, you know, if two people have the same shipping address, like making sure that they don't get the same clothes. But in general, we are looking at this problem. We call it kind of global optimization, where it's like making sure that we're not just looking at every person as a one-off situation where it's like, okay, what does the model predict for this person and then that person, but rather taking a systemic view of like, okay, we have this merch, and we have these people, and how can we distribute it amongst those people to kind of find an optimal result. So yeah, we're still kind of locally optimizing, like a stylist will log in, there'll be this merch available, and they just send the best stuff possible that they can find. But we want to get to a place where we're able to control a little bit more for like, you know, but globally, what sorts of, you know, what distribution would make the most sense.
Thank you for that. The next question is from Elijah Flurley. He asked, you mentioned the theory portion of data science and how it is taught well enough. Are you talking specifically about the stats methods and math behind data science, or is there something else that you want us to keep in mind?
That's a great question. I was sort of talking about the statistical methods. And again, that's like, I want to make sure it's clear that that was like my experience of the field. So I also like got a math degree and then like a PhD in biostatistics. So my training was like all about kind of like the central limit theorem and proving the central limit theorem and like proving all of these like, you know, various theorems. So that is what I was talking about. Like I can rattle off like a lot of things about the central limit theorem very quickly. But at the same time, like I think there's like, so for example, the thing that's popping in my head with that question is that like with data visualization, for example, there's a bunch of theory there about like how humans process imagery, what sorts of graphs are generally known to be effective. Like, you know, I'm thinking of Edward Tufte in the early days, and some other data visualization folks recently, where there are human psychology factors in terms of how we ingest data. So I actually think when I was saying we teach theory well, I was really talking about statistical theory, and that was sort of traditional training. So I think in general, actually, it would be, you know, a good idea to learn some of the theories of, you know, human psychology and like data visualization and some of this stuff. So yeah, I would encourage like again, the theory is fundamental and it is a key building block for those narratives. And so the more building blocks that you have, the more rich narratives you can build.
Okay. Our next question, why did you decide to work at StitchFix?
Yeah, great question. So all of my decisions in that whole kind of tree were, I like to think of them as very empirical decisions where like I would essentially kind of like apply to places and then see which ones I was excited about and then go with that. And so like it became clear to me during my PhD that like that was not the path for me. I really love my coworkers. I love teaching, but you know, the application was not sufficiently exciting for me. And I, you know, started to explore data science. And so when I applied for jobs, I applied to a few kind of traditional biostat and tech. And so it was like, yeah, I'm really excited about the tech ones. I'm just going to go with that, not think too hard about it. And now that I understand kind of self-reflection more, I am certain that if I tried to rationalize my decision at that point, that rationalization would have been wrong to some degree. And so in terms of going to StitchFix, it was very similar. I had the sense that like San Francisco was where it was at for data science. I think that was accurate. And StitchFix, like I was using the product, I was intrigued by it. I'd heard from colleagues in the field that they had correctly told me that like StitchFix had this huge data science team and that they felt that data science was really fundamentally core to the business. So, for example, the chief algorithms officer at StitchFix, who I put that in quotes, but that's like his actual title. He actually came from Netflix, where Netflix is a service that for a while, like 10 years ago, they were all about data. I think they still are, but at the time they were doing this whole Netflix challenge where it was like, oh, who can, like, you'll win $1 million if you can improve our algorithm 10%. And so for a while, it really seemed like data was going to be their key differentiator. But eventually it actually became clear that original content was their key differentiator. So now they've gone after, like, shows, all their original content winning Emmys. So they're more like a traditional media company. And so he actually left because he was like, well, I want to be at a company where data is the differentiator. And so, I think he correctly identified StitchFix as one of those. And so I was really into that idea. Like at Etsy, I'd always felt like it was a little bit of like, it was important, but it wasn't necessarily the fundamental thing. And so, yeah, I was intrigued by that, wanted to move to San Francisco, and it worked out.
We're running out of time.
Oh, sure. Yeah.
Thank you so much. So once again, we would like to thank our sponsors, the American Statistical Association, the Consortium for the Advancement of the Undergraduate Statistics Education, our studio, Google, and the ASA section on statistical education.
And this concludes the keynote address. Shortly within the next few minutes, we'll have the graduate school info session. Thank you for listening, and please keep watching.